I got a comment on a video asking for a automatic slide, and I thought that was a fun little change and difference. So here's a video for doing mover for an automatic slide, so you don't have to press any buttons. Still maintains the normal slide and all the functionality that comes with the normal slide. Stops you going up any hills that are too big for you to slide as well, but that's completely optional. As usual, any project files are available to gold members, so this file will be uploaded, and it does work on hills as well. So it does work on landscapes as well, as you can see. If there's a video you want to see, drop a comment, and if it's interesting enough, I'll see what I can do about it. And yeah, if this is the sort of thing you want to see, if you want to see more mover content, drop a like, drop a comment, drop a subscription, and let me know what you think and how you get on. As usual, have a great day, and I'll catch you next time. Right, we're going to open up Sandbox Mover, and then come up to the top, and I'm going to right click and create a custom event. We'll call that auto slide, and then from after this debug job, we're going to call auto slide. All right, next we're going to want a line trace. So we want to trace in front of us how far down the slope is, and then we're going to do get at location, because that's where we want to go from, and then we're going to do get at rotation, because this will be in front of us, and then we're going to do get forward vector. What we want to do is we want to get our at location and add from the forward vector, so it's in front of us. So we're going to multiply the forward vector and put that into the add, and then both of these are going to go into the start and into the end for the time being. And then we're going to right click and convert this to a float. So you can right click, convert it to a float, and I'm going to put in 200 on the multiply. Draw debug type and make 4 durations, subtract from this start and end, because these are currently starting and ending on the same point. So we're going to subtract by, let's say, 1000, put that into the end, and then we'll compile and show you that. So now we've got a trace in front of us on the floor. One problem with this trace though, if I come up to here, because the trace doesn't move with our body or skeleton, once we get over a certain point, we disappear the trace. So we're going to need to add from this get at to location, and we'll add 250 and put that add into the other add that goes into start and add. Into start and end, sorry. I've said add too much. So now we've got this line trace, and no matter where we go or how high the object is, it won't disappear. The other thing you'll notice is if I move to the right or left, it will move with us, so there won't be any problems there. The only thing it doesn't do is the back, so we need to sort the back out as well. So first off, we're going to get a branch, so we're going to drag out from the return value and press B, get a branch, get this out hit and break it, so type break in. Then we're going to do two things. We're going to get this location and break that as well, and we're going to promote this Z to a variable. This will be the front Z. So that's basically how far from our trace, the top of our trace, to the floor the trace goes. And then we're going to get the normal, and we're going to do a dot product. And then we're going to do get actor up vector. And we're going to do the A cost. Well, that gets the degrees. And then we're going to check if that is more than 30 degrees. So if the slope that we hit is more than 30 degrees, then we'll carry on. By carrying on, all we need to do is we're going to grab all of this code for the line trace and copy it, come back over here and paste it. And this will be our behind trace, so connect true to the new line trace. And then between get forward vector and the multiply, we're going to add another multiply node, connect it up, right click on it to convert it to a float again, and then make it -1. So that's now behind us. It's just inverting it. So rather than forward vector, you can think of this as the back vector. Okay, from this return hit, we're going to get branch. From the out hit, we're going to break it again, and then we're going to get our location and break that again as well. Promote the z to a variable. This will be our back z, and that can now be true. Okay, we're going to get our front z, and we're going to get our back z, and we're going to minus them from each other, and this will tell us if the slope in front of us is going down or if it's going up. And then from here, we're going to check if it's less than or equal to 255 minus 255. And if it is, we're going to get branch, and we're going to get our character mover, and we're going to add a gameplay tag. Now, you shouldn't have a gameplay tag in here for sliding. So we're going to add one. We're going to press this little green add button, and then mover, capital M, and sliding. And then make sure on source tags any. I'm going to add a new tag and select it. So if it's true, we're going to go into sliding. Right, so that's the basics sorted, but we need to go into our content drawer, movement modes, and get a transition to slide. From the and, we're going to check if we or boolean, and then we're going to duplicate this has gameplay tag and break movement component set. And instead of checking if we're crouching, we're going to check if we are sliding. Put that into the or and put that into the condition. So checks the speed at the top, checks if we're crouching. So if both of these are true, then it will trigger, or it checks if we are sliding, and then that'll trigger. So that's the movement 2. We need to go to the transition from sliding, which is in the same place, movement modes. And we're going to break movement component again, and then has gameplay tag sliding again. And just make sure we get this moving component from the break simulation tick parameters. This time though, it's going to be a not boolean. And this or will be an and. Plug that in like that. Okay. So now, if I come up to the top of this, we should now be able to slide down it. So this ACOS degrees here shouldn't be less than 30, it should be more than 30. That's on me. So greater than or equal to 30. Right, and now we should be able to slide on it. There we go. Right, a couple of problems. Obviously, we're not coming out of the slide. So we need to put a condition so that we come out of the slide. So when we get to this 255, we're going to get another branch from false. And this time we're going to get our character mover, and we're going to try get floor check hit results. This out hit result we're going to break again. And then from the normal, we're going to get a dot product. And then we're going to get the ACOS degrees. And then we're going to check if it's less than or equal to 37. The dot product needs a get actor up vector. Plug it into the bottom. Oh, and then we're not actually removing the gameplay tag, so remove gameplay tag. Sliding, if this is true. And now this should work. There we go. So it pops out of it there. Right, a couple of problems. It's not very fast. Like, we need to set a boost so that it can go all the way down once we start sliding. So we're going to do find movement mode. And then we'll get the BP movement mode slide. And we're going to set initial boost time and set initial boost speed. Boost time we're going to make 5 seconds, and boost speed we're going to make like 2000. And then up where we are adding the gameplay tag, we're going to add those. Compile and save that. We can test it. So you should see it's like shoot down here. There we go. And then we don't want that to then be, didn't even connect this one. We don't want that to then be the same when we remove the gameplay tag. So we're going to remove the values. We're going to make them 0.2 and 800 when we stop. So that then when we're sliding on the floor like this, from our normal, it's just the normal slide that we have. Okay. So, sliding down a hill. There we go. We're a little bit quicker when we pop out, so you can play with those values to make it better. And then the other thing is, once we've slid down a hill, or we don't want to actually slide up the hill at all. So we don't want to be able to get up the hill, because that makes no sense. You can walk down a hill, but you can't walk. You can walk up a hill, but you can't walk down a hill. So we can get that and change it. So back in our mover, I'm going to get our character mover, and we're going to do find shared settings. And this will be our common legacy settings. And then we do max, walk, slope, cosine. Now these are in cosines, which is degrees but converted. So I've got some values here for you. The right hand value is a degree. So I'm going to do mine at 0.85. I'm going to copy this and put it up top as well. So just before we add the gameplay tag, we're going to make sure that we revert it back to 0.71. Compile and save that. And now we shouldn't be able to walk up this hill at all. There we go, so it stops us there. And then if we go to the top and slide down it, we can still slide down the hill. So that's what we want. Problems. First off, we can slide and then sort of slide back up it when we shouldn't be able to. So we're going to go back to our mover. And what we're going to do is we're going to right click and get movement direction and offset. I'm going to get this movement direction and check that it's not equal to backwards. So we're going to make this 255, make it into an and. And then secondly, we're going to get this code that's less than or equal to 37, copy it, and add it as well. So we're going to get another and, but this time it will be more than or equal to 20. Let's tidy this up a little bit. And finally, we're going to right click and get IA move. And right click to open that and just make sure that the Y is greater than or equal equal to 0. So that's either not moving or moving forward. That fully disables the backwards move, and if we move back, then it triggers a fall instead. Like that. But if I was to slide normally, it'd all be fine. The other way of doing it is you could call the disable input on the add gameplay side, call disable input with a player controller, and then enable input when we stop that way. But then you won't be able to move sideways either. So those are your choices. And finally, we're going to get all this remove gameplay tag code just after the true. I'm going to copy that, and on the first false, sorry, on the false that we're checking if it's more than or equal to 30, we're going to plonk that code just there. And that's going to go on the false. So if it's not more than or equal to 30, then we're going to remove the gameplay tag. So now we can test it to make sure it all works. We're going to slide down this hill. I'm going to press the back button. It's going to throw me into a jumpy slide. Got a normal slide for when we're just sprinting around. And then can't get up this hill because it's too big. And if I didn't press the back button when I was sliding, I should just slide all the way down the hill. Like that, see? It's only to stop us going back up the hill. So we should have eliminated all the edge cases for this as well. But if you do find any, let me know. And then finally, this is running every tick, so this is quite expensive. And then finally, we're just going to optimize this a little so it's not running every single tick, and we can turn off the debugs so the red line doesn't appear. But to optimize this, we're going to come and grab this ACOS function to try to get floor normal one. So we're going to grab all of this, copy it, and then we'll put it on a branch. So we just need to check that this says more than 20, so that's fine. So branch here, and then we'll just check that this is greater than or equal to 18. And that's when this will start running. So this won't be running until we're over 18, and then it'll start running and enable us to sort out our code and optimize it a little bit so we're not causing so much of a strain. And there we go. So I hope you enjoyed that, and thanks for watching.